Okay, so this is the pre-development explanation. I just want to make sure that each of these blog posts is understood or, um, you know, kind of like understandable. Um, so I'm going to go through some of the key ones, just explaining each one. I'm going to try to keep this nice and short as well. So I started by looking at some libraries. As you can see here, I did a GitHub search for computer vision, which led me to these. This allowed me to, hang on, it might be easier if I just view blog. Okay, maybe not actually. So I started looking at GitHub here. I chose Python, um, and then I began looking at some libraries. This really isn't important to understand the development, but it's critical anyway. So as you can hear, I'm looking at NumPy, what it's used for. I'm looking at Sys, which how it allows me to use things. I'm looking at Pill. Pill is really important, but I don't think I'm going to use Pill anymore. But it's there. OpenCV. I'll be using OpenCV. I've got a tar and zip file and collections and IO, URL-lib and matplotlib. I said tar file and zip file because I thought I'd be downloading datasets. I'm not. URL-lib in case I had to download, but again, I'm not doing that. Matplotlib in case I wanted to use that to show pictures, but I'm not, so, you know. The next blog post, just a list of the libraries I'll be using. And I looked at some real-world applications. There's the infrared on the iPhone X. We've got car counting or traffic counting. We've got HAR cascades, which are useful for detecting facial features. And we've got some OCR examples. Here I made a program which allows me to scrape the text from that image using Tesseract, which is Google's OCR library. And then I've got some more real-world applications like pedestrian detection and counting, which are really just commercial but also have security applications. And then here I've got some negatives like deepfakes and some automatic image annotation, things like that, just some real-world applications. It's quite useful to know what it is before you jump right into it. And then here, I was looking at HAR cascades, which work by training HAR features on the. It works by training HAR-like features, where you take a bunch of positive images and a bunch of negative images, and you place the positive images over the negative images, and then the algorithm determines the difference. This is YOLO. This is more machine learning than HAR cascades. You only look once. I looked at doing this, but it was absolutely impossible. And when I say absolutely impossible, I mean definitely possible, just and not acceptable for my level. I did some corner detection because that's a good showcase of computer vision. I talked about the different things here as well, the parameters. And talked about feature matching. I thought this was pretty cool. You know, as you can see, it finds the different features. Give video demonstration. I talked about HAR cascades again, because I was under the impression I was going to use HAR cascades because it was nice and easy to detect faces. But then I thought, well, I actually want to use TensorFlow now. So then I started looking at TensorFlow. Nikhil Reddy, and he did a brilliant tutorial on how to classify or train a dataset, not train a data, to create a dataset, and then use that dataset to detect objects, and that was with transfer learning, which is obviously a very popular approach. And here I looked at what kind of application I was actually going to make, because obviously there's 1,000,001 different computer vision applications, so I had to decide here what I was actually going to do, and I concluded that I was going to make an object detection application. And then here I did some more on what I was actually going to do, and again I concluded that I will be detecting objects in a video. This is basically just some more research into what I was actually going to do. And then we're getting into the more recent posts, researching deployment. Now, deployment was quite a tricky one because I'm not at the stage of making it yet, but deployment's a tricky one. So I was talking about how I was going to do it. Now I thought about using Flask. Flask isn't exactly the best option for this because of it's a web micro framework, and so if I was going to use Flask, I'd have to send data to a web server and send it back, and it would just be a really confusing process for something quite simple. So as you can see here, the cons outweigh the pros. Yeah, and then I looked at PyQt and OpenCV, and this is definitely a better option. I created an audio recording here of what my plans are, and I concluded here that I would create an application which would detect fruit, and if it detected the fruit in question, in this case a banana, it would create a window that said found, and if it didn't find it, it would create a window that said not found. And then here I looked at the requirements for that project, and I said, yep, I'll require lots of pictures of oranges and bananas, and I found links to datasets under the MIT license, which I can take legally, and then I looked at further generation of datasets, and I concluded here that I'll be using imagery training, which, like explained in the previous blog post, is effectively transfer learning in TensorFlow. And then we're at the stage of generating the dataset now, which is a video, so it doesn't need explained. But basically, the basically what the application will do is a video will be passed to it either from webcam or from a MP4 source or something similar, and then as a result of that, it will create a window which either says, yep, the object has been found, or no, the object hasn't been found. And this is the conclusion. Thanks very much.